Okay, so a quick update on the gearbox design. Um, so I was drawing like until now there are three different designs, and oh my god, each one I need to spend like a full day on uh, each one, and also because it's too complex, it's hard to change like after the thing is finalized. So like I need to when I want to change something, I always start a new design. So like there are three now. I'm still working on this one, and it's difficult to come up with new names. But anyway, yeah. So this is the design, and I've tested it in the previous video. So like it's on my main channel. It can pull two 25 like 500 milliliters. So basically it can pull 1 kilogram at 40 centimeters, which is pretty decent. But there were some accidents happen when testing. So firstly, the shaft, it's the weak point of the entire gearbox. So this one, it's 3D printed, so it is easy to snap at the bottom. So I had one shaft snap during testing. But although like the situation was the arm was shaking due to poor pit tuning, so like it was vibrating violently, and like I think the force is pretty big, and then it snapped the input shaft on the motor. But anyway, so this is the weak point. But well, it's hard to solve, and I don't think I can solve that in like without huge change to the structure, because like the firstly the limiting factor is the bearing here. I'm the biggest one I have with like reasonable thickness is this one. Uh, so 8 millimeter inner diameter and 3.5 millimeter thickness. So I'm using like 3.5 millimeter for the cycloidal discs, and so the wave generator, or like the eccentric bearing, yeah, eccentric shaft. This one is 8 millimeters, which is pretty thin. Like, oh, I don't have the thing here. It's pretty thin. Oh, I got one here. Yeah, so that's already pretty limiting. And I need to figure out a way to like attach the input shaft to this, because like this one is wider than the bearing here. So these two need to be separate parts. The other way to do that is like I can combine this part to this part and like separate here. But I don't think that's easy either. Wait, actually, no, I don't think it's worth it. Because that way two discs will bear different load, and I don't think that's a good thing. Yeah. So anyway, this is the previous design, and I was using the same design on version 2. And on version 3, I discovered that I can actually. So now the shaft is extending from this stick to through this part. So extending this way. Alternatively, I can make it going this way. So I can make this part extruding into this part. But then I realized that there's a hole here, and that is for the motor. Motor has an output shaft of like 3.5 millimeters. And with that, the input disk thickness is like 4 or 5. So I don't have, I actually don't have enough space for the top part to extrude inside here. And another way is to do an offset extrusion, because like this part is offset, it's not on the center, so I can like draw a square here, but I'm not sure how it will perform under load, because like then these two parts, oh my god, what's happening? Because these two parts are different parts, and I would rather make it like ensure it to stay straight instead of like wobbling all the way around. So yeah, I think I'm going to stick with this design for version 3. But one thing I can change is, so currently the outer diameter is 68 millimeters with the screw hole pattern of a 60 millimeter diameter circle on the 60 millimeter, on a circle of 60, and that barely fits with the motor. Like I can open up design version 2. I import the motor model here, so you can see here the screw hole. It's barely not touching the motor, and in the actual assembly that is the same thing. Yeah. And I thought it was really cool. I still think that is really cool. Like like the tolerance. The motor is, I think, 61. Oh, 56. Yeah, 56. And I think the distance between the screws is 56.1. So like that amount of tolerance. Yeah, but during testing, like I was testing this one, and because of the design, the entire reducer will wobble, or like it will deform a bit on the load, and when it deforms, the motor will be scratching the screws, and so that's the cause of this line here. That's fine, but well, I don't think that's a smart choice of making it like this tight. So coming back, I think I'm going to increase the overall diameter to like, oh my god, to outer shell of 72 and a screw pattern of 64 diameter circle. It will be thicker than this one, but well, I think it's worth it. Yeah. Oh my god, there's too much thing to talk about for this reducer. Okay, and another point is like for so I have two flavors for the gearbox motor combo. One form factor is like I have the output shaft directly on the top face of the module. So this way it's 15:1 reduction. And the other one is like the arm, which the output shaft is on the outer shell. So basically the housing is spinning. And I think that's like, I'm not sure, either 14:1 or 16:1. Yeah, but anyway, so the problem is with this one. So I was using like 40 by 50 by something bearing here. So the output shaft is a 40 diameter circle. But like I'm planning to mount 2020 onto the thing, and I discovered that, well, this is a tight fit, like too tight. I'm not confident. I'm not confident in it, because like see how thin this wall is, and that's because the screw pattern is too tight. So in the new design, and this is because like the bearing is too small. So in this design, I'm planning to use a bigger bearing so that I can have like different two kind of screw patterns. So this one is the same as the one on here. So that's 16 diameter circle, I think. And also I have a like a bigger one, 20, I think. Yeah. So hopefully that will solve the problem. And on this side, okay, so for this design, this is the problematic one. On the other end, I'm just using screws with what's the name of this? I forgot. But like this part, washer to hold the bearing. And no, it will get loose over time. Like I can already rotate it by a few turns now. So this will get loose over time, which is not good. And I think it will contribute to the instability of the output shaft. So I'm planning to add another disc on the other side, like this. So the screw will like pass through and the nut will be here, and then it can be tightened. But the disadvantage point of this design is it will get thicker by a few millimeters. So the gearbox overall design, I think it's already too big, because I'm planning to use it in like humanoid robot with actual human size. So like for even for shoulder joint, this assembly is, well, a bit too cumbersome. Yeah, like compared to the servo design. Well, on the side note, I've tried to calculate how much torque these motors can output. So there was one equation which is like, I don't know, 8.3 divided by kV rating or something. So I got the result of like 110 kV. Okay, so it's actually from the spec sheet of this motor. So on the spec sheet, it can output like almost 1 Newton meters torque, and with a 15-to-1 gearbox, that's like 15 Newton meter. So 150 kilogram centimeter, compared to this like 35 kilogram centimeter. So that's, I don't know how many times of output. So yeah, I'm pretty confident on the output capability of this thing, because like I've tested this one, it can just barely raise the entire arm, which is, well, functional but not optimal. So this one, well, I'm sure it will do the job of moving the robot. But, well, considering the size, yeah, this is too big. Oh my god. And actually, and what traps me the most is like the actual gearbox, which is doing the things. It's like each disc is 3.5, so 7 or 8 millimeters in total, compared to like this, like a ton of wasted space. Oh my god. Yeah, I don't know what to do. And another thing is the encoder. Yeah, have I finished the previous part? Yeah. So size, yeah, it will get a bit thicker and a bit longer compared to this one. I don't know, it might be too big. So it will be hard to design the outer case, because if it's this big, the motor itself will be part of the outer, like the outline of the robot. So I need to be careful how to mate the actual shell part to the structural part. Yeah, but that's for future. Yeah, and also the backside of the thing. So ideally, I've seen a bunch of like similar motor designs, especially with that flavor. So normally people would just mount all structural part on this side, so that on this side it can be just a metal shell and without screw holes, and it will not bear the load. But for my case, because for example, for shoulder, because it is a 3 degree of freedom shoulder joint, I need to mount one joint like this, and the motor will be here. Let me get a part. Okay, this will be a long video, but never mind, just documenting everything before I forgot, or when I want to know why in the future. It will be like this. So the motor will bear the load, and also this entire structural part will bear the load of the entire rest of the arm. Yeah, so I need that part to be to be sturdy enough, and I also need to mount the encoder on the back. So the motor driver board, that's still a problem. That's still an issue, because this thing is out of stock. So I need to make my own one. But I can choose to make it an entire plate, like with the driver circuit included, or with a separate driver just similar to this one. And for now, I think, I don't know. Because if I'm going to do an entire board, I need to allocate another layer here. Because like the encoder position is fixed, it can only be here because the motor shaft, it's protruding from the base. And also I need to stack another magnet onto here for the encoder to read. So it will be just at minimum flush with this plate here, which is like 5 or 4 millimeters from the base of the motor. So the PCB will be here, and I need screw patterns on top of the PCB. So that will be these parts stacked together like this, and I'm going to mount like on this side, which again makes the entire gearbox much longer. And also I need to think about how to make the PCB not bear the load of the entire arm. So oh my god, that's frustrating. So now I think I'm just going to mount the encoder here, just the encoder, and with standalone motor driver, and using similar structural parts like this one. Yeah, another thing I was hesitating is whether to make it 2 flavors like these or just one single flavor, because I really do like how this one works, like the side outputting style, but I cannot combine other parts. Like I'm going to need this kind, at least for this position, because I need to, oh my god, because I need to mount the servo on the body frame, which is like pretty ideal actually. So I can mount it on this side and not let the motor bear the load, but I need the output shaft in the middle, and with a similar like C clamp structure like this, and mount another like side outputting joint here, and another like center outputting joint here, and connect it to the beam. Okay, yeah, so yeah, I'm going to need to kind of, okay, that's that. What do I also need? Yeah, for a screw pattern, I think that's solved. Also, I will need the adapter plate from the motor to either beam or some structure. And this huge ugly part is going to be needed here, because like the thickness that's required. I mean, I don't think this is structurally reliable, like considering the weak point around this thing. But okay, I draw the correct, like the encoder PCB with correct screw holes, so it will at least be like flush with this side. So this part can be thinner, which is a good thing. Okay, what else I need to say? So gear ratio 15:1, I think that's pretty good. It's pretty backdrivable, but also with enough reduction. Cycloidal gear disc thickness 3.5, I think that's okay. So currently I have no method to mount, like to secure the bearing with the 3D printed parts. It's just friction mounting. Yeah, friction mounting. But it works now, and I don't think that would be a huge issue. Like the cycloidal disc isn't going anywhere else. It's stuck in the housing, so that's fine, I guess. Okay. And and also I was going to say, like, I'm also considering like whether I should use the 2020 beam or not, because like, oh my god, this is complicated. Oh my god, this is complicated. Because for the arm here, this 20 centimeter beam is already too long, like compared to actual human hand, because I need another motor here, which is going to be getting longer than the current one. So it will be definitely longer. So I need to see like whether I could get shorter beams. And also I don't think the beams themselves will be very strong compared to like their weight. So alternative solution is to 3D print the tube here, but that's a large print, and that's not. So I need to design that and to print that, and that takes time. So I'm going to stick with the beam. So the weak point then will be the mounting point, like how to secure this thing. And with a bigger screw hole pattern, I think I can make a better job than this thing. So it will be longer and wider. So it will be fine. Okay, everything will be fine. Good. Okay. And also I need to think about what this joint should look like, but that's not on the topic of this gearbox because, well, it will be too big for this joint. Yeah, it's already too big for this one. Like, see. Okay, that's actually good. Okay, never mind. Yeah. But, well, the robot will not look too slim, I guess. That's what I'm trying to say. So yeah, okay. Problem solved, I guess. I can have enough confidence to continue drawing this design. Oh, and also Fusion messed up with my timeline. So, I don't know. I may need to start another sketch for this thing. Yeah, all kind of bugs. Okay, that's the update. I hope I can draw another version and print out and test like within 2 days. Okay, so the current plan, because I don't have motor drivers, now I have two 110 kV motors. I've bought another like thinner 240 kV motor. This one, it is indeed thinner. So I don't think the torque will be too high. But, well, and another same size, but 310 kV. So I can also test that. So 4 motors, and also those are in stock. These variants are in stock. The 110 one is out of stock. But because the gearbox should be standalone like this, so my plan is to like settle down on one design ASAP and print out a bunch of them, assemble like at least one arm structure and test. And if I found any critical bugs, I will run another iteration, but hopefully I can be done with it and like let this one be the final design. Hopefully. Oh my god, hopefully. Yeah. So that is the update. I feel that's just a bunch of complaints with a little bit of information within. But anyway, hopefully everything will work out good. Oh my god, yeah, another point is I found like with this size, I need 25mm length screws everywhere. Like one for this mounting and one for the motor mounting. And I just discovered that in my like standard screw collection, there is no 25mm. Like from the shortest one, it's incrementing by 2, and then by 4, and then it reaches 20, and then jump to 30. So this is one screw box collection. These are like the longer screw box collection, and they don't have 25mm. And it is hard to get. I have bought it on Amazon, like I don't know, 50 pieces, and that takes 2 weeks to ship. So I don't think 25mm M3 screws are a standard thing. So I'm not sure whether I should use it in my design. And an alternative method is to use not the machine screws, but the where is it? Like the slanted head style. Where is it? Like those with flushed head. And I can solve the problem with a 20 millimeter long one, but okay, I cannot find it. But well, that's a different kind of screw, and it uses one size smaller screw head, which is easier to get damaged, and because that's a different screw type. So in my design, I'm going to have two different kinds of screws. So I don't think I should use it. But well, the other way, 25 millimeter, that's also non-standard. So oh my god, I need to decide on that. Yeah, let's see, I guess. Okay, see you.